We're going to do number 4.
Yeah. There we go.
It's like G of n plus 1 equals 3 minus 4x squared. What does it mean to evaluate? Oh, I see it. So you plug it in, you put it in, substitute, you will solve. So if we're putting this equation in for x, that would look something like this. And then we need to simplify. So this is being squared, so that's the same thing as n plus 1, n plus 1. Distribute and keep combining like terms. N squared plus 2n plus 1. And then you need to distribute your negative 4. And combine your like terms.
Oh, okay, I see.
Questions on this one? Make sure you get this written down. Make sure your name is on your answer sheet. And once both of those things happen, pass up your answer sheet. Did you have a question, Logan? Decide change 6 and
Did you guys eat at Rose?
Alright, do I have everyone's answer sheet? Take out these notes. We're going to go back to this one last time. I know the last time I saw you, I told you to go ahead and try the remaining 4 left over, so that was 6 through 9. And I just want to see if we have any questions on 6 through 9. We need to see it, need clarification on any of those 4. So this one's 5, but I'm talking about 6, 7, 8, 9. 8, yes. Alright, we're doing number 8. Alright, so remember that you need some, like, original, I'm gonna, from now on, call it parent table to kind of base these numbers off of if you're doing it transformation-wise. So your x's are your -1, 0, 1. if you didn't have any transformations, it would just be e to the x. So if you put these numbers in, you'd have some 1 over e, which remember, you just need to know that that's 0.37. You'd have some 1 and some e, which you just need to know that's 2.72. And then you could apply your transformations if this is the way you're doing this. We have 1 horizontal and 1 vertical, so I'm going to write that off to the side. We have a horizontal reflection. Horizontal reflection or reflection over the y-axis. And then we have a vertical shift up 3. So that means we're going to add 3 to our y's and multiply our x's by -1. So our new table will be 1, 0, -1, 3.37, 4, and 5.72. And then we can graph those points. Here we had a vertical shift, so that is still our asymptote. Y equals 3. We can graph that first. One, 3, 7, 0, 4, -1, 5, 2, 5, close enough. Look something like that. So this looks like it's decaying, but it was really reflected over the y-axis. Our domain for this is what? Still all real numbers. Our range for this? Everything greater than 3. We were given our y-intercept in our table, so 0, 4. We also have that point. Is this increasing or decreasing? Decreasing at all. Numbers, not increasing at all. And then as x goes to -infinity, y goes to infinity, and as x goes to infinity, y goes to 3. And remember, if you're doing it the other way, just using those 3 numbers, which we technically still did, you were just taking those x values, putting them into your function, and figuring out what those y values are. The only problem with that, especially with is you get more decimals, more fractions, and the graphing piece won't be calculator. I don't think there'll be an E on there, but the graphing piece won't be calculator. Do you have any questions in general about graphing exponential functions? I gave you another packet. We're not going to do that entire thing. The packet of notes I gave you is kind of what I did last year, so I just want to take a piece from it. So look at those notes. The front of it looks like this. You could definitely go back and do these 2. They might help you determine transformations. And remember exponent rules, so that's for you. I need you to find this page. I think it's the 5th page, maybe? I don't know if they have numbers on them or not. So this is just finding some of your characteristics without graphing it. You'll need to be able to do that as well. So if you have to find these characteristics, you're going to be given some general equation, some general exponential function. Yeah.
Does the base do anything other than show you
It basically does that. Shows you whether it's growth or decay, and that kind of changes some of the points.
so
You can-
how big?
Yeah, it doesn't really affect it much. You could kind of think about it as a growth is kind of like a stretch, and a decay is kind of like a shrink. But then if you were multiplying it on the outside of it, then it also does that. So, but not really. So we're gonna do in these first 6. We're gonna do like one of each, so you can see the different types. So here you are asked to find your transformations. What happened to get this? So, we have a horizontal asymptote in number 2. That means what?
There's no sign.
So I think you're thinking rational functions. The horizontal asymptote is determined by what? If you're looking back at your graphs. The shift. What type of shift? The vertical shift. So there was a vertical shift down 2 because of this horizontal asymptote. So you need to be able to connect those two. I see horizontal asymptote, there had to have been a vertical shift. We're also going to find the new function as well, since this was the original. This is our new y-intercept. Our original y-intercept should be at 0, 1. If there was only a vertical shift, we could literally apply this to this and see if we get this. Meaning, if I subtract 2 here, would I get this? Yes. So that means there was only a vertical shift, and that is it. So this function would look something like y equals 2 to the x minus 2. Questions on that part? Yeah. So that part was given to us. This part was given to us. We just found this. The vertical shift down to. Yes.
How do you know the original y-intercept is at 0, 1?
So if you're thinking about any general function, like even if I did this one, the original table is that -1, 0, 1. If we put those values into this, we get 1/2, 1, and 2. So that y-intercept is 1. City.
So can the y-intercept ever be like wrong? So like when we subtracted 2 and it didn't give us a y-intercept, like what happened?
Not that it's wrong, but there's something else there also. So like this one was just a vertical shift. This one, I'm assuming is the one I'm talking about. Number 4 is the same. I want to do one of these. It doesn't really matter which. So let's do number 1. I should have just started with that one. It's okay. Here, our horizontal asymptote is 0. What does that mean?
There's no
There's no vertical shift. So that means in these cases, you're either going to have a vertical shift or a horizontal shift. I want to say you won't have reflections, but I'm not 100% positive on that. So If there's no vertical shift, that means there's some horizontal shift that made it do this. So we're going to set this up to look like this. 2 to the C, because that would be some horizontal shift. We know it has to equal 0. I'm sorry, I said that wrong. We can put plus 0, but we know it needs to equal 1/4. The plus 0 is not necessary. So whatever our horizontal shift is, gave us 1/4. So we're going to solve this. What could I put in for C to make this 1/4? -2. So if I put 2 to the -2, that would give me 1/4.
English.
Yeah.
I'll think of -1.
Which means we have, so this function would look like y equals 2 to the x minus 2, which means this was moved right 2. So be very careful, even though it says the negative, you're really still moving right.
So it's not negative 2.
Because it was a horizontal shift, not a reflection. So if you don't have a vertical shift, you can assume that there was a horizontal. And then there's cases where there's both. Questions on one before we do one of these? We're going to do the one with the fraction. Don't let the fraction mess you up too much. It's going to be the same process for this. Okay. Here we have a vertical shift, obviously because we have this. If, from the first one we did, if we just added 2 to our original y-intercept, would we get 9/4?
No.
No. So that means there's also a horizontal shift. That's how you can tell those both. So if you took your original, you added 2, you would not get this. So that means there's also a horizontal. So now we're going to kind of set it up like we did number 1. We're going to set this equal to 2 to some c. We don't know what that c is yet. However, in this case, there's also a vertical shift. So plus 2. So our c is going to be a negative something. But you just need to solve this. Kind of how we did the other one. There's just an extra step here. Subtract 2 from both sides, and then figure out what your c is. So if I subtracted 2 from both sides, I get 1/4 equals 2c, and we still get -2 as that c. So that means there was a vertical shift up to plus and a horizontal shift right to.
Yeah, what? Oh, we have to simplify.
Yes.
Okay. So far.
So just to recap what we did. We set this up just like we did in number 1, except there was an extra step because we had a vertical shift. And then we are solving this. So subtracting 2 from both sides would give us 1/4. And then you're trying to figure out what could C be to make this 1/4, and that would still be that -2. Putting that -2 actually into your function, that would be your function, y equals 2 to the x minus 2 plus 2. And you had two transformations, a shift right by 2 and a shift up by 2. What questions do we have right now? Yes.
Do you always have to start at like 0 or 1?
For your y-intercept, yes. Now, those you were given your y-intercept and a horizontal asymptote, you had to find your function and your transformations. These, you just have to find your y-intercept. How would you do that? Set x to 0. So for all of these, they're going to be fractions. I'm just going to do 1 because they're all going to be about the same. So if I put 0 in for x, that would give me 3 to the -3 plus 2. And then you have to be good with your exponential rule, exponent rules. There we go. So this will be 1 over 27 plus, what is 2 times 27? 54. You're going to need to convert the whole number to a fraction to combine these. Doesn't have to be. You can change it to a mixed number. That would be fine. But you do need to do this step. Find that exponent rule.
Thank you.
Sorry, not exactly. 0, comma. That or
Oh, you said we can do it.
yeah. So 4, 0, 2, and 127.
What would be a mixed number?
That's right.
But it does need to be in one of these two formats. Now, anytime you have a negative up here, you're going to end up with a fraction. Anytime you have a positive, you won't. So I'm just going to take this and make it positive. You'll like the ones that are positive because you don't have to do all that fraction work. Because that was just going to be 25 plus 4. But you do need to know your perfect squares and cubes in order to do so. I'm going to give you the rest of class to do the remaining 3 problems up here. Find these y-intercepts. If you need more practice on either of those, on the last page in those notes is a section for that. So go through those and do as many as you need to. I will post the answer key to that last page so that you have it.